Section 1.7 is titled Simplifying Expressions. So let's first look at some properties of addition and multiplication. You've learned these before, so these are review. The commutative property says that you can add numbers in any order and multiply numbers in any order. So on the left-hand side, we have two examples, addition and multiplication. 2 plus 7 is equal to 7 plus 2, and 3 times 9 is equal to 9 times 3. On the right-hand side, these are just examples using letters, so those are true for any numbers. The associative property states that when you are only adding or multiplying, you can actually group any of the numbers together and still get the same answer. So on the left-hand side, we have an addition example and a multiplication example. So first we have 6 plus 8 in parentheses, then plus 2. But on the right-hand side, we have 6 plus 8 plus 2. So if we were to actually solve this out, PEMDAS says we have to do the parentheses first. So 14 plus 2 is 16. But on the right-hand side, we would have 6 plus 10, and that's also 16. For the multiplication example, 7 times 4 is 28. Then we multiply by 5, and 28 times 5 is 140. On the right-hand side, we have 7 times 20, and that is also 140. Again, over here, these are just examples using letters that indicate real numbers. So this is how you would look at it, true for any numbers. Let's look at some examples to simplify using the associative and commutative properties. So what we have here are possible multiplication or addition problems where if you just do it in order, we may or may not know the answer right away, or it may be a little more difficult to solve. So we're going to do some rearranging so that things are easier to solve. 1/3 times 5 is not a nice number. It's still a fraction, but if I switch the 5 and the 33 and I write 1/3 times 33, then times 5, I'm able to do 1/3 times 33 because I know that I can cancel and I get 11. So this leaves us with 1 times 11 times 5, or 55. And then, so was it the associative property or the commutative property that allowed me to switch the order? It's the commutative property that allows you to change order. Let's look at an example with addition. We have 45 plus 16 plus 55 plus 4. And oftentimes with addition, it's easiest if you can have yourself adding 10s or 5s together. So if I switch the 16 and the 55, I have 45 plus 55 plus 16 plus 4. 45 and 55, that's 100. 16 and 4 is 20, and now I can get 120. It's much easier to add this way than to try to add from left to right with the original problem we were given. Again, it's the commutative property that allows us to switch the order. So again, continuing on, we have 15 1/3 plus 4 plus 1 2/3. If you'd like to pause the video here and see if you could rearrange the expression here and see which way it's, so that you can find the most simple way to add it. I would switch the last two terms, so 15 1/3 plus 1 2/3 plus 4. And the reason why I'm doing that is I'm recognizing that 1/3 and 2/3 is going to give us a whole number. So 15 1/3 plus 1 2/3. 15 plus 1 is 16, but the 1/3 and 2/3 is going to give us 17. 17 plus 4 is 21. In the bottom example, 7 isn't divisible by 2, or if you multiply 7 times 1/2, you get 3 1/2. It's much harder to multiply that times the 8. So if we use the commutative property, 1/2 times 8 times 7, we can cross cancel here. And we end up with 1 times 4 times 7, or 28. The distributive property is another property I want you to know, and that says that you can multiply a number by a sum or multiply each number in the sum and then add. The result is still the same. So on the left we have 3 on the outside of a parentheses, and inside we have 4 plus 8. The distributive property says we're going to take 3 times 4, then take 3 times 8, and add those two sums together. 12 plus 24 is 36. On the right-hand side, this is just the example using the letters to represent real numbers. So let's write the product using the distributive property, and then we want to simplify. If we take 5 times 59, most of us don't know that right off the top of our head. We'd have to do quite a bit of mental math. So let's make it a little bit easier. Let's rewrite 59 in terms that are easy to multiply. 50 plus 9. We're under the understanding that that is 59, and I can break that down using the distributive property. Now I want to distribute the 5 through. So I'm going to take 5 times 50 and 5 times 9. 5 times 50 is 250. 5 times 9 is 45. And it's much easier to add these together. 250 plus 45 is 295. Let's do another example. We have 8 times 33. So think about how could you rewrite 33 using the distributive property to make it a little bit easier on yourself. We would say 8 times 30 plus 3. So the distributive property says 8 times 30 plus 8 times 3. 8 times 30 is 240. 8 times 3 is 24. Now when you add those together, you get 264. It's much easier to multiply that way and add and use addition than to just try to figure out what 8 times 33 is. So let's look at some vocabulary terms. The first word is terms, and those are the parts that are to be added or subtracted and are separated by addition and subtraction signs when we're looking at expressions. Like terms are terms that contain the same variables raised to the same powers. So in this example, 4x minus 3x plus 2, 4x and 3x would be like terms. That's because they both have an x to the first power attached to them. A coefficient is any number that's multiplied by a variable. So in this example here, 4 is a coefficient because it's directly in front of the x, and so is this 3. And actually, if we add the opposite, you'll notice that's a negative 3. So let's simplify the expression. You can simplify expressions anytime you have like terms somewhere that can be combined. So on number 7, we have 16p plus 84p. Both of those are like terms, so we just add 16 plus 84, and we get 100p. We don't do anything to the variable when we're just simply combining or adding and subtracting like terms. Number 8, we have 3m squared plus m cubed. Remember, the definition of like terms stated that the variables had to have the same exponents. These do not have the same exponents, so this is actually already simplified. We can't simplify this any further. In the last example, we have a negative 20t plus a negative 8.5t. These terms both have t to the first power, so we can combine them. So we simply want to add the coefficients. We have a negative 20 and a negative 8.5. So we're actually going to add those two numbers because they're both negative to get 28.5t. And then remember that since they are both negative, our answer takes that same sign. So when you're simplifying algebraic expressions, you can use many of the properties that we talked about to simplify, and those properties are your justification. So here's a long example here with a table where you have a procedure that's been done and then you need to justify it. So the first line here where we have 2 and then in parentheses x plus 6 plus 3x, that's the original problem. So what you need to do is go through a series of steps and justify how you were able to do each step. So from the original problem down to the second step, you can see that the distributive property has occurred. 2 times x plus 2 times 6. So the justification is the distributive property. Then from step 2 to 3, we have 2x plus 12 plus 3x. You can see multiplication occurred, the 2 times 6. So we multiplied. In the fourth step, we have 2x plus 3x plus 12. You can see that the 12x, the 12 and the 3x have switched places. That's the commutative property. The associative property allows us to group with addition or multiplication. So we have grouped 2x plus 3x and then have the plus 12 in the back because of the associative property. Then we combine like terms, 5x plus 12. In class, we'll work on worksheet 1-7, and you will have to be able to do some charting like that last example. So make sure that you look over that for a few minutes and understand what each step means.